Hey everyone, when you see those wild images of devastating floods on the news, it's so easy to just think, wow, force of nature, right? An act of God. But is that the whole story? Well, in this explainer, we're going to dig into the powerful and often invisible human hand that might be making these floods a whole lot worse. So let's just dive right into that big question. Are floods really just an act of nature? Sure, heavy rain is always going to be the trigger, but it turns out it's not that simple. The way we build and manage the land around our rivers can be the difference between high water and a total catastrophe. And that's what we're talking about, the human factor. We're going to see how our decisions can completely tip the scales. But to really get how this works, we first need to understand the big picture, the entire system all this water flows through. And that brings us to a really key concept, the drainage basin. The easiest way to think about it is like a giant funnel. Every drop of rain that falls within this huge area of land eventually gets funneled into one single river. It's a beautiful, natural system, but it's a system that we are fundamentally changing. Let's look at how.
Okay, so where do we start? Well, with the most obvious change, something I call the concrete connection. This is all about the impact of our growing towns and cities. Urbanization.
Think about it. In a natural field or forest, rain hits the ground and just soaks in. But in the city, we've replaced all that nice, soft soil with what are called impermeable surfaces. Things like roads, parking lots, and buildings that water literally cannot get through. So instead of soaking in, all that water has to go somewhere, and our storm drains are designed to do one thing: get it to the river as fast as humanly possible.
And wow, this slide just shows you the stark difference. In a natural basin, the river rises kind of slowly, gently. But in an urban basin, it is the exact opposite. You get almost no infiltration, super fast runoff, and this sudden, really dramatic spike in the river's level. And geographers actually have a name for this.
It's called a flashy hydrograph. And honestly, flashy is the perfect word for it. The lag time, which is just the time between the heaviest rain and the river hitting its peak, is incredibly short. The river just swells up violently and quickly, totally overwhelming its banks. This is a direct consequence of that concrete connection.
But it's not just our cities. Let's zoom out to the wider landscape for a minute and see how we're also losing our planet's natural sponge, thanks to deforestation and some types of agriculture.
I love this analogy because it's so true. A forest is basically a giant sponge. The leaves and branches catch the rain, and the roots open up the soil, letting it absorb just huge amounts of water. So you can probably guess what happens when you take that sponge away.
Yeah, you get this crazy chain reaction. Without trees, more rain just hammers the ground directly. Without those amazing root systems, the soil can't soak up nearly as much water. This not only means more runoff, but it also causes soil erosion. All that loose dirt gets washed into the river, literally clogging it up and making the channel too small to hold the water it's supposed to.
And you know what? It's a really similar story with some intensive farming practices. Heavy machinery can compact the soil over time, basically squeezing all the air and life out of it, making it much harder for water to soak in. Then, you add in artificial drains designed to whisk water off the fields, and you've got the same problem we saw in the cities. Way more water getting to the river way faster.
Okay, now for a really fascinating twist. What about the stuff we build specifically to stop floods? This is the great paradox of what's called hard engineering, where sometimes our so-called solutions can actually make the problem a whole lot worse.
So, hard engineering is basically our attempt to control a river with brute force. We're talking about building big, physical structures. Think concrete walls or levees along the banks, or even straightening out a river's natural meanders to make the water move faster. The intention is good, but oh man, the results can be a disaster.
This four-step process on the slide just perfectly shows the classic downstream problem. So a town floods. The solution? Straighten the river to flush the water away faster. But in doing that, you've basically created a fire hose aimed directly at the next town, which now gets hit with a huge volume of water moving much, much faster than it ever would have naturally.
Levees can cause a similar problem. Rivers have natural floodplains for a reason. They're nature's safety valve. They allow the river to spread out, slow down, and lose energy when the water is high. By building walls to stop this, we're bottling up all that water and energy in a narrow channel, which just increases its speed and power. And if those defenses ever break, the flood can be incredibly sudden and way more destructive.
So what is all this telling us?
It's telling us we have to stop trying to control a river in one tiny spot and start thinking about how to work with the water across the entire system, the whole drainage basin.
This table is a fantastic summary of everything we've just talked about. Urbanization swaps soil for concrete, which means faster runoff. Deforestation takes away that natural sponge, giving us more runoff and clogged rivers. And hard engineering, our big fix, often just shoves the problem downstream and makes it worse for someone else.
So here it is, the absolute bottom line. A natural drainage basin is a beautifully balanced system. It's designed to absorb, store, and then slowly release water. Every one of these human actions we've looked at, from paving a parking lot to building a levee, messes with that natural balance. We are systematically taking away the landscape's ability to deal with heavy rain on its own.
And that leaves us with one last thing to think about. Instead of constantly fighting the water, we need to learn how to work with it. So I want you to look around your own community. Can you spot the concrete connection? Can you see where we've lost our natural sponges? Or hey, maybe you can spot signs of smarter ways people are starting to live with our rivers. What does working with water look like where you live?